Okay, so today's lesson, 4.1 on classifying triangles, is all about telling you what type of triangles there can be. We can have various types of triangles. Just like in Unit 1, we learned that there's different types of angles, like an obtuse angle or an acute angle. We can have different types of triangles. So the classification of triangles is done two ways. We can classify the triangles based on the angles inside the triangle and based on the sides of the triangle, whether we have sides that are equal or not equal. So the classification is by angles and by the sides. So the first classification is an acute triangle. Now the word acute is an angle that measures less than 90. So an acute triangle will be a triangle that has three angles that are less than 90. Three angles that measure less than 90. An example may be a triangle that has one that is 60 degrees, that's less than 90, 40 degrees, that's less than 90, and 80 degrees, that's less than 90. This is called an acute triangle because all three angles are less than 90. The next type we call is an equiangular triangle. Now, an equiangular triangle, if you look at the word here, you see equal, okay, and you almost see the word angle in there. So this is a triangle that has equal angles. So a triangle that has three equal angles. Now you've probably already learned that in a triangle we know that the three angles inside will add up to 180. Look at my example before up here. I have 60 plus 40 is 100 plus 80 gives me 180 degrees. Every single triangle that you have will add up to 180 degrees. So in essence, when I have an equiangular triangle, I know all three angles will add up to 180 and all three have to be equal. Well, if I take 180 and I divide that by 3, 180 divided by 3 will give me 60 degrees. So each angle in here will measure 60 degrees when it's equal angular. So it's a 60 degree measurement here, three equal angles. The next triangle is a right triangle. A right triangle is a triangle that has one right angle. So it's a right triangle that has one right angle. So if we draw a right triangle here, we know that it has one right angle. The other angles doesn't matter what they measure, okay? But you know you have a right angle there, it's a right triangle. And lastly, we have an obtuse triangle. Obtuse triangle, well, you probably guessed it by now, has an angle that measures more than 90 and less than 180. In other words, an obtuse angle in it. So it's a triangle that has one obtuse angle. This is an example of obtuse triangle because this angle here, 110 degrees, is an obtuse angle. So this would be called an obtuse triangle. So those are the 4 ways to classify by angles. Okay, so these 4 is how we classify by angles. So we classify by angles by acute, 3 angles less than 90, equiangular, 3 equal angles, they will all be 60. A right triangle has 1 right angle, an obtuse triangle has 1 obtuse angle. The other way we can classify, which is the last 3 here, is by sides. If the sides are equal or not is how we classify them. So the first one we're going to talk about is a isosceles triangle. That's when we have 2 equal sides. A triangle with 2 equal sides is an isosceles triangle. So if this is equal and this is equal, but this is not, okay, then it's isosceles. So pretend like this is 10, this is 10, and this is 12. This is an isosceles triangle because 2 sides are equal, 1 side isn't. Equilateral triangle. Equilateral, you see the word equal, and lateral is a Latin word for side. So this is equal side triangle. So this is a triangle with 3 equal sides. A triangle with 3 equal sides. So equilateral will have 3 equal sides. So let's say this is 5, this will be 5, and this will be 5. That's an equilateral triangle. All 3 sides are the same. And lastly, we classify a triangle that has no equal sides as being called scalene. So a triangle with no equal sides is scalene. This would be scalene because 6, 7, and 8, none of them are the same. So that's a scalene triangle. Any questions on how to classify by angles or sides? Now, I want to dig a little bit deeper into this. Angles and sides relate. So in essence, if you have a triangle that has all three angles equal, you're going to have a triangle that has all three sides equal. So an equal angular triangle, that's a triangle with three equal angles, will also be an equilateral triangle that has three equal sides. So this triangle here, I know all three angles are 60 degrees because it has three equal sides, it has three equal angles. In isosceles triangle, it has two equal sides. When it has two equal sides, that will mean it has two equal angles. And lastly, a scalene triangle, it has no equal sides, it will have no equal angles. So the triangles and it has its sides and angles relate. If the angles are equal, the sides will be equal. If the angles are different, the sides will be different. Okay, let's move on to page 2 here and do a few examples. So, example number 1. Find all angle measures and then classify each triangle and explain. Okay, so let's do the first one there, triangle EFH. Okay, I'm going to highlight it. EFH, this triangle right here. Now, first thing I want to do is find the angle measures that are missing here in this example, because I need to know those angle measures in order to identify and classify the triangles. So if you look right here, these two angles here are forming a linear pair, which means they add up to 180 degrees. So if this is 60 degrees, this angle right here will be 120 degrees. 120 plus 60 gives me 180. The other angle I'm missing is right here. Now this whole thing is 90 degrees, but that's the big angle right here, but it's separated into two parts. So the smaller part here measures 30 degrees. Well, 30 degrees plus what gives me 90? And that would be 60. So this would be 60 degrees right here. Okay, so now I have all my missing angles. I can classify the triangles. So back to that first triangle here, EFH. What do you notice about that triangle? What in particular stands out? Well, a few things should. First of all, this has what type of angle here called? 120 degrees. It's obtuse. So I know that it's an obtuse triangle. What else do I know? Well, you should also notice that there's two angles that are the same measure. Both are 30 degrees. Now, if you have two angles that are the same, that means you have two sides that are the same measure. Okay, so if I have two sides that are the same measure, that means I have an isosceles triangle. So this is going to be called an obtuse isosceles triangle. Okay, let's do our next one. In our next one here, we have triangle EHG. EHG. So in this one, this angle here, E, is 30 degrees, G is 60 degrees, and the whole angle H is 90 degrees. You should notice then that this angle here, 90 degrees, means that this is a right triangle. Now, I classified it based on its angles, but I want to also classify it by its sides like I did up here, saying this was isosceles. What type of triangle is this? Well, again, the angles and the sides relate. So if this is 30, this is 60, and this is 90, none of them measure the same. And if none of them measure the same, that means none of the sides will measure the same. And so it has to be scalene. And lastly, that is triangle FHG. In triangle FHG, which is this one right here, you should notice that all three angles are 60 degrees. When you have all three angles 60 degrees, that's called equal angular. And again, if it's equal angular, we also know that it would be equilateral, because when you have three equal angles, you have three equal sides. And we're done with example 1. So what I want you to do right now is try to classify example 2, all those triangles. So go ahead and take a little bit of time to do example 2. Okay, so let's go over example 2. So in example 2, I want to find triangle ABC. Didn't classify that triangle there. But here is ABC. Now, you should notice a few things. Well, first of all, if this is 15 and these have slash marks through it, that means this triangle here, side AC, measures 15. So now when you look at the whole triangle here, 15, 15, 15, all of them are the same. So when you have all three sides the same, it's called equilateral. Now, we know the sides and angles relate. So if this is equilateral, it means it's also equal angular. Okay, that was A. Now let's go on to B. In B, we're going to do triangle A, B, D. In triangle ABD, this is 15, this is 18, and BD, the whole thing here, is 15 plus 5, which is 20. So none of the sides measure the same, and when none of the sides measure the same, it's called scalene. So triangle ABD is a scalene triangle. Now, I can't determine what type of triangle it is, if this is a obtuse angle here, or a right angle, or an acute angles here. I can't classify that any further on that part. So the only thing I know for sure is that this is a scalene triangle. And in C, triangle ACD, or ACD, this one here, and this is 5, 15, and 18, and because this is 5, 15, and 18, they're all different. This is scalene. These are obviously acute angles. This one here looks like it measures more than 90 degrees, which would put this as an obtuse angle. If this is drawn to scale, then I can probably assume that this is obtuse, and I can say it's scalene obtuse. However, because I don't have any angle measures here, I don't want to assume that it's drawn to scale, and that's why I would just say that it's a scalene triangle. And that is example 2. Let's move on to example 3. In example 3, we want to find the side lengths of each side. Well, a common mistake would be to say 2x plus 3 plus 8x minus 9 plus 5x minus 2 equals 180. Any ideas why that's wrong? And what you were doing, those people who might have thought that, is that this is a triangle and, oh, 180. Well, 180 relates to the degrees of angles, not sides. Sides will never add up to 180 degrees. Sides, okay, are either going to be congruent, okay, or if I give you a perimeter, then you can add them up and equal to a perimeter. But you cannot add them up to 180 degrees. Okay, so let's get back to how we could solve this then. Well, you see this slash mark here that tells you that LK is equal to JK. Now, if LK is equal to JK, all right, then I can set these two sides equal, and since they both have the same variable, x, I can solve for x. And once I can solve for x, I can substitute back in to each side. So I can do 2x plus 3 equals 8x minus 9. And then solving this, I can subtract 2x, which leaves me with 3 equals 6x minus 9. Add 9. So 12 equals 6x. Divide by 6, x equals 2. And now that I have x, I can find each side. So jk is equal to 5 times 2 minus 2, which is 10 minus 2, 8. And lk is equal to 2 times 2 plus 3, which is 4 plus 3, 7. And jk, I don't even need to substitute in because I know these two sides are equal, so it must also be 7. Now, based on that information, even though this doesn't say classify it, I can classify this as an isosceles triangle because two sides are equal and one isn't. So this is an isosceles triangle. Okay, you're going to try example 4, but before you try it, let's go through some things you should be noticing here. This means that angle G, angle F, and angle H are equal. So angle G, F, and H are equal. Now, if they're equal, that should tell you something. Okay, go ahead and try this example. So, after trying example 4, let's go over it. So like I said before, these three angles are equal. If they're equal, it means this triangle is equiangular. And if it's equiangular, it's also equilateral. So it means all three sides are the same measure. So, how could you solve this? Well, you can only have one equal sign. So you have to take one of these two sides and equal them. So I can either take 3y minus 4 and equal to 5y minus 18, or I can do 2y plus 3 equal to 5y minus 18, or this one equal to that one. It doesn't matter which ones you choose, since they're all supposed to be equal. You'll find y, and then you can find each side. So I'll do gf equal to gh. So I can do 3y minus 4 equals 2y plus 3. Solving that, minus 2y. So y minus 4 equals 3. Add 4. Y equals 7. Now that I know what y is, I can substitute back in and have every side. So fg is equal to 3 times 7 minus 4. 21 minus 4 is 17. So that's 17, GH will be 17, and FH will be 17. making an equilateral triangle. Okay, that ends 4.1 for today.